Hi, and welcome to the video. I'm David Walters, a Principal Solutions Architect in the AWS IoT Partner Team. In this video, we'll discuss common challenges that connected product service providers face as their number of devices that connect into their cloud infrastructure continues to grow. First, I'll cover the basics of AWS IoT services designed for operational device fleets. Next, I'll cover various scenarios based on real-world customer experiences and short demos of how to solve them with AWS. First of all, let's discuss why device management is important. With many options on the market, customers who buy connected products such as smart home devices expect that their devices will be reliable and available on demand. Customers want their devices to be free from bugs and introduce new value-added features. And finally, they want devices that are secure by default, especially as more devices end up in their homes and personal space. Understanding the health of a connected device fleet is complex, as the amount of data about the operational status of millions of devices is large. It's too large for a single human to look at all pieces of data all the time. So you need tools to collect, aggregate, and organize the device fleet into operational requirements. The number of devices connected to IoT is growing day by day and is estimated to reach 28.5 billion devices by 2030. So how can you meet customer demands of premium support, reliability, and security at scale? Let's talk about two AWS IoT services that are designed to help you navigate these challenges. So how can you manage a growing fleet of connected devices? With AWS IoT Device Management, you can register your devices securely at scale. This means onboarding device identity automatically to ensure that devices in the field connect securely to the cloud. Device management provides options for this, such as just-in-time provisioning or just-in-time registration and fleet provisioning. It's not enough just to onboard the devices to the cloud. Once you have thousands of devices connected, device management allows you to tag, group, and organize those devices based on device type or operational requirements. Once your devices have been organized, you can search through them to find devices relevant to you at any time. You want to know what's happening with both your fleet of devices, as well as view the status of any individual device on demand to investigate issues. The IoT Jobs feature of device management also provides robust over-the-air commands and firmware updates to roll out large-scale actions to your fleet of devices. Finally, in some cases, you will need to access a device securely, wherever it is in the world with secure tunneling. This means, for example, SSHing to a device deployed in the field securely to fix or investigate any ongoing issues with the device. Of course, managing the device fleets are not enough. You also need to ensure that they stay secure throughout their lifetime. With AWS IoT Device Defender, you can monitor your AWS IoT configuration, detect devices for abnormal behavior based on defined thresholds or machine learning models, receive alerts, and automate mitigation actions such as quarantining devices. So let's look at a couple real-world customer scenarios and how to address the scenarios with AWS IoT Device Management and Device Defender. Your smart home product is gaining significant success, and you have sold over 1,000 devices deployed that have connected into AWS IoT Core. Early customer adopters have already gained new updates, but many new devices are coming online every day running older firmware versions that shipped with the device. You need to organize this device fleet to see how many devices are running each version of firmware. And you need to set up some basic monitoring and a quick dashboard to see the overall fleet status. Devices that onboard to AWS IoT appear in the Thing registry. Dynamic thing groups in the AWS IoT Thing registry allow you to group devices based on searchable attributes using fleet indexing queries. You can write fleet indexing queries such as the one displayed here to group devices. In this example, we create a thing group of all connected devices that report running version 1.0.0 in the AWS IoT device shadow. When a device no longer meets this criteria, such as if it disconnects or receives a firmware update, it will automatically be removed from this group. You need to aggregate some data about your device fleet. You can write fleet indexing queries that run periodically, and the fleet metrics feature can perform calculations, such as the total number of devices that meet the fleet indexing query, or the average of all the reported values, and send these metrics to Amazon CloudWatch. For example, you can write a query to count all of the devices that report running version 1.1.0, or how many devices are currently connected, or how many devices have less than a 20% battery level. Most fields searchable by fleet indexing can become a fleet metric. Amazon CloudWatch collects logs from AWS IoT, including default metrics such as device connection and MQTT publish and subscribe events, and additional events from AWS IoT features such as the AWS IoT rules engine. Combined with fleet metrics, you can create detailed dashboards that give the user a comprehensive but simple view into the current status of all devices in the fleet, as well as visibility into when significant events occur. I will show a demo on how to use fleet indexing to create dynamic thing groups based on firmware version reported from the AWS IoT device shadow. Once the devices are organized, I will show you how to build an Amazon CloudWatch dashboard. From the AWS IoT console, let's take a look at our connected device fleet. So I currently have 1,000 air quality sensors connected to my AWS IoT Core device gateway. If I look at one of the devices, I can see that it has a name of AQ sensor and then a unique hash. It has a certificate attached to it, and it has a device shadow. The device shadow is a name shadow called metadata, and inside of this device shadow, there's a couple things that are reported, including the firmware version, its location, and its current battery level. Now we'll look at how to search through the device fleet using the fleet indexing feature. You can write queries based on any indexable attribute. So I'm going to write a query to see all connected things running firmware version 1.0.0 as reported in their device shadow. When I click on search, I can see that there are currently 278 things that are running firmware version 1.0.0 and are currently connected. So I can confirm that by clicking one of the things, looking at its device shadow, and it is currently reporting version 1.0.0. Putting this all together, we want to use fleet indexing to dynamically group our things into groups based on requirements. Here I will create thing groups based on firmware version that each device is running. So when I click on thing groups, create thing group, I'm going to create a dynamic thing group. I'll call this AQ sensor firmware 010. And the query that I'll write is shadow.name.metadata.reported.firmware version 0.1.0. And we'll just preview that query, and you can see there are 242 devices that have version 0.1.0. And I'll create the thing group. Next, I'm going to create a few thing groups for each of the known firmware versions. I've completed creating all the dynamic thing groups for version 0.1.0, 1.0.0, 1.5.0, and 2.0.0. Now let's create some fleet metrics to send to Amazon CloudWatch. I'll start by creating one for all connected devices. So I'll go over to the fleet metrics console, create fleet metric, and the query that I want to run is connectivity.connected equals true. The aggregation field is connectivity.connected, aggregation type is statistics, and I'm going to select the count of all of the devices that match this property. Click on Next. I'll give it a name. And I want this to run every minute. And if I click on Create Fleet Metric, it'll show up in my Fleet Metrics dashboard. And I'm going to create a few additional fleet metrics, including all the disconnected devices, as well as the number of devices currently running each version of firmware. Now that I've created all of my fleet metrics, I'm going to navigate over to the Amazon CloudWatch console to create a CloudWatch dashboard. So I'll click over here in Dashboards and create a new dashboard. Call this AQ Sensor Fleet Dashboard. And I'm going to add my first widget. So what I want to show is the number of connected devices and number of disconnected devices. So I'll use a pie chart to show that. I'm going to choose Metrics, IoT Fleet Metrics, and I'll choose AQ Sensors Connected and AQ Sensors Disconnected, and create widget. So now we have a pie chart showing the number of devices that are connected and the number of devices that are disconnected. And if I hover over it, I can see that 100% of my device fleet is currently connected. So that means that there's 1,000 devices connected currently. So next, I'm going to add a few more widgets onto the dashboard. So now I can see how many devices are running each version of firmware. So I can see that in a pie chart format. I can see that it's pretty evenly dispersed and the exact numbers of devices running each version. I can see the number of devices connected over time. So I might see a spike in this graph if I had a large connection event, or a decrease in this if I had a large disconnection event. Likewise, I have the opposite graph, the number of disconnected devices. If this spikes up, that might indicate that there was an event that happened at some point, as well as the number of connect events themselves, and the number of messages published at any given point. Also have over here on the left, I've got my connected devices pie chart and the number of all disconnected and connected devices. Using this CloudWatch dashboard, I can now view the overall state and health of my device fleet. Now that you have a comprehensive view of the overall status of the connected device fleet, you want more fine-grained monitoring of each device in the field. It's not possible to view all of the data coming from each connected device at all times, so you need automated monitoring and detection of any anomalous events. Devices that are misbehaving should be removed from the operational fleet as soon as possible while investigation is ongoing. This prevents any bad data from a compromised device from leaking into your production data. Using Device Defender Detect, you can define a security profile that sets up the default behavior for devices. For example, you know that each device reports a single 500-byte payload every minute. Device Defender Detect lets you set up thresholds so that if a device reports a payload larger than 500 bytes, it will trigger an alarm, send a notification to Amazon Simple Notification Service, and allow you to trigger custom mitigation actions. By installing a device agent on each of your devices, you can monitor additional metrics, such as the number of open TCP ports, and report this to the cloud, or even define your own custom metrics, such as CPU usage. Security profiles can be set up manually or using machine learning detect. Device Defender will monitor your device fleet for normal behavior and build a machine learning model to detect anomalous events. Device Defender has a number of pre-built mitigation actions that can be triggered on any detect or audit findings. For example, a device that misbehaved can be moved to a quarantine group with a restrictive IoT policy that does not allow the device to publish any data. You can create custom actions by triggering an AWS Lambda function from an SNS topic as well. In the next demo, I will show how some misbehaving devices can be detected with a Device Defender security profile, receive an alarm on the AWS IoT dashboard, and move the devices into a quarantined thing group. From the AWS IoT console, I'll navigate to Security Profiles under Device Defender Detect, and I'll create a new security profile. In this case, I'll create a new rule-based anomaly detect profile. I'll give it a name called AQ Sensor Security Profile, and I'll have it target all of the registered things in my AWS IoT Core device gateway. I could optionally set an SNS configuration. I'll skip it for the demo, but you might use this to receive an email when one of your devices has been detected as misbehaving, or also do additional automatic mitigation actions, such as using the SNS to trigger an AWS Lambda function. So I know that my air quality sensors typically report messages that are 500 bytes and below. So what I want to do is I want to select the message size as a metric behavior, and I want to send an alert when the message size is greater than 500 bytes. So just to review, I have a profile name of AQ Sensor Security Profile. It's targeted to all registered things in the AWS IoT registry, and it will trigger if a device sends a message that's greater than 500 bytes. So I'll click on Create. The next thing I need to do is set up an automatic mitigation action. So before I do that, I need to create a quarantine thing group. And for the purpose of the demo, I already created it. So this quarantine thing group has an IoT policy attached to it. So all devices in the quarantine thing group will no longer be allowed to connect or publish messages. If I go into mitigation actions, I've also set up the mitigation action, which essentially moves every device that I set to this mitigation action into the quarantine thing group. From here, I'll navigate to the alarms page to see if any devices have violated the security profile that I set up. After a few minutes, we can see 3 devices have violated their security profile. So I want to mark these and start mitigation actions. So the action I'm going to do is move them into the quarantine thing group, and I'll click on Start. After a few minutes, we can see that the 3 devices that violated the security profile have disconnected. Now that they've been quarantined from the operational fleet group, we can start to investigate the reasons why they violated the security profile. You've detected an issue with some of your devices, particularly new ones coming online for the first time, and it's affecting the customer's experience. You want to resolve those issues quickly and securely, and ensure that all new devices coming online will receive an update automatically. IoT Jobs lets you send JSON documents to devices that describe an action to perform. Devices can accept the document and perform the action, or reject the action. The devices use MQTT to receive the notification and publish messages to the cloud to update the cloud on the status of the job execution. For example, IoT Jobs is most frequently used for device firmware updates. Jobs are designed to be highly scalable for a fleet of devices. You can target a single device or a thing group for the jobs and monitor their execution in real time. You can see how many devices receive the update at once and failure criteria to roll back or immediately stop a job in the event of failures. Finally, you can control when the job is rolled out. So you might set the window to happen between 2 and 4 a.m. during the hours of least usage to ensure customers are not affected. Often, devices are manufactured with the first firmware and sent to distribution channels. By the time customers buy them and connect them, you may have already fixed critical issues or rolled out new features. By using the IoT Jobs continuous rollout feature, you can target devices that join a specific thing group to be updated as soon as they come online and join that thing group. Once the device has been updated and reports its new version, it will join the thing group with all of the updated devices. In the next part of the demo, I will show how to set up a continuous firmware update job for all devices running firmware version 0.1.0. If you remember, that had the corrupted data bug found in the previous demo. All devices coming online will join the thing group for firmware version 0.1.0, receive the IoT job, and once completed, they will be moved to the 2.0.0 thing. Here we can see one of the devices that was quarantined. If we check its device shadow, we can see that it's running an early version of firmware 0.1.0. After investigating all the quarantine devices, I discovered that all three of them were running the same firmware version. So I need to update all those devices to run the latest version. So under the Remote Actions tab, I'll go to Jobs and then Create Job. This is going to be a custom job. I'll give it a name, Update 010 to 020. The job target is going to be all devices in the current firmware version group of 010. I've already created a job template and a job document. The job document is a JSON document that's sent to the device and specifies how it should update itself to the newest version of firmware. The job run type is going to be continuous. I want this firmware update to target all existing devices running 010 and all new devices coming online in the future. There are many different rollout configurations and scenarios for IoT jobs, but for the demo, we're going to set up the job to roll out to 100 devices per minute. I'll set a timeout of 5 minutes, and this means that after 5 minutes of receiving the job, the device didn't update its status, it goes into a timeout state. And the job will retry 3 times before it fails. Finally, if 10% of the devices in progress fail, I want the whole job to be canceled. Finally, I'll click on Submit. From here, we can track the progress of the firmware update. You can see that currently 9 are in progress, none have succeeded yet, and none have failed yet. If I refresh the page, we can see that the job is rolled out to 44 devices and 1's queued. After a few minutes, we can see many of the devices have completed the firmware update. 240 have succeeded, 2 are still being queued, and 2 have timed out. The job will not complete even if all of the current targets complete the job because it is set to a continuous rollout. So new devices will be targeted as soon as they meet the criteria. Finally, we can see the CloudWatch dashboard to see how the firmware update affected the overall fleet health of the devices. Now we can see there's only 3 devices in the firmware 010 group and 477 devices now running firmware version 2.0.0. We can also see when a large bunch of those devices disconnected to receive the firmware update, and we can see that a few of the devices never connected after receiving the firmware update, indicating a failed firmware update. Knowing when an event happens to your device fleet and how it responds collectively can help you respond appropriately to the events. For example, when AWS IoT Core updates, it will disconnect a percentage of the device fleet in a rolling window. Infrastructure needs to scale up to handle the large volume of new messages, especially if you're not using managed services for downstream infrastructure. Ultimately, this is to minimize the impact on your customers for any large-scale events. AWS IoT Core provides detailed server logs, and more fine-grained device logs can be acquired by having devices send their logs to reserved AWS topics. In Amazon CloudWatch, you can use to search through the logs and configure alarms when thresholds are met, such as a certain number of disconnect events in a specified time window. From there, you can perform actions such as send a message to an SNS topic, send an email, or configure an EC2 auto-scaling action. Alarms can be added to your CloudWatch dashboard for easy viewing. In the final demo, I will configure a CloudWatch alarm to detect a large-scale disconnection event and see the alarm after such an event occurs. Starting at the CloudWatch console, I'll navigate to Log Groups. AWS IoT Core stores log files in the AWS IoT Logs v2 log group. From here, I can use the search function to find specific events. For example, I can search for all events of type disconnect that happened in the past 3 days. I can pick a random event and see the details such as the timestamp, the device, which is the client ID, and the reason for the disconnect. So in this case, it was a server-initiated disconnect. I want to set up a metric filter so that I can count the number of disconnect events in total. I'll give the filter a name called disconnection events and put it into a new metric namespace. For every event, I want the counter to increase by 1. Next, I want to create a new alarm. I'll select my newly created metric filter called disconnection event. I want to alarm when the sum of all events in a 5-minute period is greater than or equal to 100. In other words, when 100 disconnection events happen within 5 minutes. Now I can send the alarm to an SNS topic, and in this case, send an email. I'll give the alarm a name and a description, and finalize the creation of the alarm. Now I want to add this to my CloudWatch dashboard. CloudWatch has a widget specifically for alarms so that I can add it to my dashboard and any device manager can view this dashboard and see the active alarms at any point in time. So let's fast forward a few minutes and wait for a large disconnection event to happen. You can see the alarm turn on in the dashboard when it occurred. We can go to the alarms console to get more information. From the alarms page, you can see exactly when the event occurred and respond appropriately according to your operations. Connected products present a number of challenges that AWS IoT helps you solve. First of all, we have to ask the question of why we are connecting devices to the cloud. We do this to give our customers great experiences and turn the data that those devices generate into new innovative ideas. In order to maximize the value from connected products, you need to minimize your IoT operating costs. You can do this by using AWS IoT services to connect and ingest data from millions of devices without worrying about the underlying infrastructure. Using AWS IoT Device Management and Device Defender and some of the techniques shown in this video, you can maintain operational visibility and security to manage large fleets of devices. We talked about challenges of maintaining and monitoring a large device fleet, various real-world customer scenarios, and how to solve them with AWS IoT and other AWS services. I hope you will use these techniques to continue success of your growing connected product device fleet.